Yep. So what exactly is motion in a vertical circle, and how is it different from uniform circular motion that we have discussed before? Well, usually the circular motion that we have discussed is more on the horizontal plane, like on the top of a table. If you have a string and a ball and you're rotating it around the table on the horizontal plane, is essentially governed by the laws that we discussed in NLM, and it was like the uniform circular motion, and we discussed angular displacement, angular velocity, and everything for that. This one is slightly different because it is happening in the vertical plane. So that means the background here, the white background here, can be thought of as a wall instead of, you know, a table. Okay, so this is happening in the vertical plane, and we have to talk about everything related to this, as in when exactly, like for example, when the particle is at the bottommost point, it's at the bottommost point, and obviously in the vertical plane this cannot happen without a string. So you have to understand this thing is actually attached to the center by a string right here. So we are talking about this ball right here, and this ball is attached to the string. Okay guys, sorry about that. So yes, so as the body is moving in this vertical circular motion, I need to make an FBD for the particle at the bottommost position. So यहाँ पे whenever the particle is at the bottommost position, what are the forces that are acting on this block or on this bob? Well, if you think about it, there's only like two forces acting on this: mg, downward direction, and tension in the upward direction. Now this thing changes as we change the location of the body. Like when the body goes to a different location, you will see that the tension, okay, so the tension is acting. So where's the marker here? I think let me use the red color to show. This is the direction of tension at this location. Okay, what I'm going to do is make this ball move to a different location, and make the FBD at that location. So for example, when the body is right here, okay, in this location, if you make an FBD, how will the FBD look like? Well, this is the block and this is the wire. Well, if you make the FBD in this case, well, the body will be something like this. Okay, the mg force will still be acting downwards. It will still be acting downwards because mg is not something that depends on the orientation. The mg force is actually, you know, just always acting, you know. So let me put this in a way that it makes more sense. So given the relative position of the block, so this is where I am taking, right, the body's location. So this is the path, the circular path. So if I make the FBD at that location, you know that the tension has changed. The gravitational force mg's direction does not change, but the tension ka direction has changed. Okay, and one more thing, if it's doing a circular motion, is it experiencing any sort of acceleration? Well, yes, it is always accelerating towards the center. So that means here there's an acceleration like this. At this location, the acceleration would be like this. So every time the ball is moving at different location, the direction of acceleration will be always pointing towards the center, because that's how centripetal force is defined, right? What is the you know, direction of centripetal force? Well, it is always towards the center. So you know that the acceleration is also not unidirectional. It's more like changing with time. When it is doing that vertical circular motion, the direction of acceleration changes at every instant, right? Now if I had to write an equation, okay, depending on any time theta, let's say this angle right here is theta. Usually we measure the angle that the string is making with the vertical direction, and we define it as theta. We kind of define it as theta. And in that case, can you write an equation for the centripetal acceleration using NLM? Right? At the bottommost position, you'll be writing a simpler equation which says ki, okay, T minus mg is going to be equals to mv square by r. Yes, because T is in the upward direction, mg is in the downward direction, and these two forces are adding up to become mass times acceleration. Now you know centripetal acceleration is given by the velocity square by r. So this is actually nothing but the second law, which says sum of all the forces is mass times acceleration. This is what I have written here. This is what I have written here. But in this case, since this is making an angle of theta, guys, can you tell me what this angle right here is? Because I have to resolve the forces, so you gotta tell me how much this angle is. I think from corresponding angle, this angle also becomes theta, right? So in here, the equation would not be T minus mg. It would be something like, at this location, the equation would look like T minus mg cos theta would be equals to how much? Well, mv square by r, right? So the value of tension, the value of mg is not going to change, right? If we assume that the velocity is constant, then you can see that the tension needs to be different at different locations. Do you understand what I'm saying? At different location, the tensions need to be different values. Okay, so as long as you're able to understand up to here, we should be okay. Okay, so if you have any doubt, you can always ask. Because if you take the components of the gravitational force, then mg will have two components. One component will be along this, which will be mg cos theta, and one will be perpendicular to this, and that will be mg sin theta. So in the direction of acceleration, in the direction of centripetal acceleration, you'll have T minus mg cos theta. Can someone tell me what role does mg sin theta plays? Well, it's going to bring the ball towards the central position. Now you know that if you take a ball and you raise it to a certain height and you release it, it's going to tend to come towards the mean position, which is like the central position. Why does it happen? Well, because of mg sin theta. Mg sin theta is the force which is responsible for trying to bring it back towards the mean position. Guys, up to here, this is like the basics of what is happening. I haven't started vertical circular motion yet. But if you have any doubts in this, again, feel free to ask. Okay. Now, another important thing that people sometimes need to understand, and all of this I'm doing before I start talking about the vertical circular motion, it has something to do with this. Okay, so let me fill this with black so that I can only have the outline. Also, let's make this a little bit heavier so that you're able to understand. So imagine for example, there's a body which is going to do a circular motion. So this is the string, the dotted line is the string, and the string is attached to the bob, and the bob goes up by a value of theta, right? By a value of theta. So it's like a pendulum, and the radius of this is r. One thing that I have repeatedly told, and this being this angle here being equal to theta, is that sometimes we want to know how much is the height that the ball gained. Because if you want to solve this in terms of energy, you will always want to know how much elevation did it create, because as we have discussed yesterday, gravitational work done or potential energy due to gravitation does not depend on the path. So you just at the end you just keep on asking, sir, when it moved by an angle of theta, how much high did it go from its original position in the vertical direction, right? So there is an easy way of doing this, and for that I need you to understand that you can always make this particular triangle a right triangle by dropping a perpendicular right here, right? Now if you drop that perpendicular, you can find out this OZ distance. OZ distance comes out to be how much? Well, if you solve this right triangle, you know this side OZ is like the base of the triangle, so it's going to be r cos theta. This is basic trigonometry, right? But we also know that OP, let's call this point P, OP itself is r, right? So if the body moves by an angle of theta, so how much elevation does it create? Well, that it creates an elevation that is equals to OP minus OZ. okay, and that is nothing but r minus r cos theta. So that's r in brackets 1 minus cos theta. Please let me know if you understood this. Okay? Now here now up to here if you understood, let's move forward. Okay, let's move forward. Now the next segment that I want to talk about is what exactly is the velocity that you need to give a body at the bottom. So for example, if there is a body right here, okay, and it is attached to the center using a string, what initial velocity do I need to provide so that this ball does like a complete circular motion? Okay, now I have done this in class. You know, if my velocity is not enough, it's going to go up to here probably and then slack off. Okay, so it will follow that yellow line up to here. So if I draw it with yellow, that will actually make more sense. So if the body goes along this path like up to here and the velocity is not enough, chances are it will fall back like this. So you need like a very minimal, that there is a value of velocity beyond which only it can do a complete and steady circular motion, and our job is to figure that out, right? But for that I need to talk about what exactly happens at the highest position. Okay, and from extensive discussion in class, I know for a fact that at the highest point the body will not be at rest if it is doing circular motion, right? Because you know, at the highest point also there is a force acting downwards and it is equals to mg, right? And at the limiting case only mg is acting. Like you can think of, okay, tension might also be acting because it is still connected to the string, but we can consider tension to be zero for now, and we'll talk about why exactly tension is zero at the highest point in a bit. But right now just consider that there is mg force acting downwards. Now if the body does not have any velocity at the highest point, it will not go this way, right? It will just fall down. It will fall down because there is a downward force and it has no velocity, so it's just going to fall back. So I have seen people say this, okay, and remember this height right here, from here to here is r, and from O to P is r, and O to let's call this x. O to x is also r. So the total height is how much, guys? 2 times r. So they will say, okay, whatever kinetic energy I give at the bottom, so let's say this body has like u velocity at the bottom, so you're gonna say, okay sir, half mu square is the kinetic energy. This is the kinetic energy at the bottom. Okay, and because I'm taking the origin of the potential energy here itself, like this is the reference line for potential energy. This is the reference line for potential energy. So you're gonna say, sir, kinetic energy plus potential energy, which is 0 at the bottom, will be equal to the potential energy at that height, which is nothing but mg into 2r. Okay, and then from this calculation you're gonna get u equals to root 4 gr. Okay, but there is something wrong with this, and I've discussed this in class. So please let me know what is wrong with this analysis. Yes, awesome. At the highest point you cannot have the body come to rest. If it does so, then it's gonna fall back directly in a straight path and it's not going to do circular motion. So we need to understand that at the highest point itself there is going to be some potential energy, some kinetic energy as well, that we don't know how much it is as of yet. Okay, but from conservation of energy, I know that the kinetic energy at the bottom plus potential energy at the bottom should equate to the potential energy at the highest point plus the kinetic energy at the highest point. But we don't know how much the kinetic energy is at the highest point. For that, what I'm going to do is make an FBD of the body at location X. So yeah, don't forget the color code. Let's make it with red. This is the body at the highest point. So if you talk about the forces, there's only one force acting on this, mg force. Okay. For now let us also consider like the tension force. So tension is also acting downwards because you know tension always acts along the string away from the body. So in this scenario it has to act downwards because the string is downwards. Okay, and mg is always acting downwards. So what do I write? How do I write the second law for this? Because it's doing a circular motion, even if it's at a constant speed, which it is not. Okay, at the highest point, it will have to feel the centripetal force acting downwards, because at the end of the day it is a circular motion, and circular motion, even in circular constant velocity constant speed scenarios, like uniform motion scenarios, there's always an acceleration that is acting towards the center. Okay, it is acting towards the center. So you're gonna say something like, okay, T plus mg is equals to mv square by r. Now this is just you saying, okay, so the net force adds up to become mass times acceleration. Okay, so in here again, mg is something that's not going to change. So if I want the minimum velocity, if I want to find out the minimum velocity, just at the limiting case when you are sending in that with u velocity and it's just able to do that circular motion, you have to take tension equals to 0. That's because you can increase or decrease the value of tension depending on what is the velocity at that instant. Because mg is the constant, tension becomes directly proportional to v square. So as the velocity at the highest point is more and more, the tension is also going to increase. But we are not asking for the maximum limit of velocity. That would be dumb, because the answer would be just infinity. You send it with infinite velocity and it's just gonna go and do that circular motion. We want that bare minimum velocity, which is just enough for it to do the circular motion. So for that, we need the tension to be equal to 0. So you just get, okay, mg becomes equals to mv square by r. Now I'm going to do one more step. I'm going to multiply with r on both sides and divide by 2. So it's going to become mg r by 2 on the left hand side, and on the right hand side it becomes mv square by 2. Now what do I get out of this? What do I get out of this? Well, I get the kinetic energy, because half mv square is nothing but the kinetic energy at that height. So if you plug that value in here, the unknown quantity mgr by 2 here, and then you solve this question, how much did you get, guys? You get something like, okay, so yeah, you get u as under root of 5gr. Okay, so people who are uncomfortable with vertical circular motion, this is that minimum velocity. This is that minimum velocity which you need to give a body at the bottommost location, okay, in order to for it to be able to do one complete circular motion. So now my question to you guys is this: if you send with root 5gr, okay, and there could be very many different questions based on this particular topic. Okay, so we have to be very careful not to memorize. The only thing I think that will be helpful in memorizing is this part, under root 5gr is the minimum velocity. Other than that, everything that we do, you need to understand the concept behind this rather than memorizing the stuff, right? Because it's not going, believe me when I say it, it's not going to help at all if you try to memorize the results that we are going to derive next, right? So for example, here if I ask you, okay, I send it with let's say I send it with root 6gr. Okay, my question to you is, if I send the body with under root 6gr, will it do a circular motion? First question, will it do a circular motion? So the first part is really easy. Well, it's greater than root 5gr. So yeah, definitely yes. Next part is, find me the value of tension at the highest point and also at the lowest point. If it's doing circular motion, that means the string will have tensions, right? So at the highest point, how much is the tension, and at the bottommost position, how much is the tension? Or also find me what is the tension at an angle of 60 degree with the vertical. So 60 degrees with the vertical. So 60 degrees with vertical. Find out tension at all these locations. So T1, T2 and T3. Figure out all these values. Okay. Cool. Although the answer is correct, I'm not convinced with the, I don't know, but did you make an FBD? No. Why? Are you a physics student or art student? If you are a physics student, you gotta make FBDs. That's your identity right there. Okay, as a good physics student, you gotta make FBDs for everything. You gotta show the forces. If you're not, then I'm gonna call you out. I'm gonna call you art student. Okay, so if you make the FBD of this, at the bottommost position, tension is acting upwards and mg is acting downwards, and this whole thing is accelerating upwards with v square by r. But v at this, or u square by r, and u at that location is how much? Root 6gr. So if you write second law for this one, Trisha, help me out with this. How will I write the second law? Okay, T minus mg is equals to yes, m into u square by r. Okay, so listen, please understand that sometimes you can be correct calculation, but the underlying concept is wrong. That's what happening with Trisha here. Okay, you gotta understand that there's nothing. I never said that centripetal force is real. I always said centripetal force, some or the other force, will be acting as a centripetal force. So you saying that mu square by r is a centripetal force is completely like it's not correct. It's completely wrong. Okay, so you gotta understand that here I have written sum of forces. So the only two real forces acting on this is T and mg, and u square by r is the acceleration. So you're writing F equals to mass times acceleration. So you do understand that here A is u square by r and m is equals to the mass, but you gotta understand mu square by r is not a force. It is mass times acceleration, and T minus mg is the centripetal force, right? And I said that whenever you are thinking from the perspective of, if you are on the ball itself, there's something called centrifugal force, and that's a pseudo force that acts opposite to the direction of the non-inertial frame of reference acceleration, and that you can say that, okay, mv square by r would be acting downwards. Now this is what mu square by r will be, a force acting downwards from the perspective of a non-inertial frame, which would be the ball at the bottom and you would be standing on top of the ball. But that's not what we are doing. We were using our simple second law, and we are saying that, okay, tension minus mg is equals to a mass times acceleration. You got to understand the difference between the two. Okay, centripetal force is not a force of its own. Any of the other forces like tension, mg, electrostatic force, any other force could act as a centripetal force, right? So T minus mg is equals to mu square by r ka significance भी you have to understand. Okay, so here T minus mg becomes okay, so T becomes equals to what? Mg plus mu square by r, so which is absolutely correct. Like I mean Trisha I think started with this only, sir, T equals to mg plus mu square by r, but you gotta understand here that mu square by r is not a force. Well, at least from the ground frame of reference, it's not a force. Okay, it's mass times acceleration. Understand the difference. There's minute difference. Okay, so mass is given to us as, okay, so it's mg, and mu square by r is m by r, and u square would be how much? Well, it is given to us in the question as 6gr, so you go 6gr, so r cancels, so you get mg plus 6 mg, so your tension at the bottommost location is going to be 7 times mg. I hope that makes sense. Okay, so second location T2 is at the highest point. So again, if I make the FBD at the highest location, guys, can you tell me what are the two forces acting on this bob? Well, there is mg acting downwards and tension also acting downwards, and the acceleration is in what direction, guys? It is also acting in the downward direction, and it is equals to v square by g. But we don't know how much this v is, because they told us that the velocity is sort of like 6gr at the bottom, but we don't know when it reaches at the highest point the velocity reduces, right? It's not going to remain same as root 6gr. It's going to be something less. Anybody knows how much this velocity will be? Yes. So we can say from conservation of energy that at the bottommost position, you're gonna say that the potential energy plus kinetic energy at the bottom will be equal to potential energy plus kinetic energy at the topmost position. It will be equal to the potential energy at the topmost position. Okay, so do this and tell me what is the velocity at the highest point, guys. Yes, guys, you found out how much the velocity at the top is. Okay, so help me find this out. So at the bottommost location, the potential energy will be 0, kinetic energy will be half m6gr, right? And the highest position, the potential energy will be mg into 2r, and the kinetic energy will be half mv square, right? So because v is something that we do not know, so it's going to be 3 mgr is equals to 2 mgr plus half m v square, right? So the kinetic energy at the top would be something like mgr, so velocity would be root 2 gr, right? Yeah, guys, why am I getting different answer from you? Okay, you got the same thing. Cool. So we're gonna say, okay, we know the value of v square now. So in the NLM equation though, from this the FBD of this, what you're gonna say about the forces? Again, use second law here, please. And Trisha, is this a force? No. Okay. Cool. Yes. Then give me the equation. Give me the second law. What are you gonna say? You're gonna say plus T plus mg is the net force, which is acting as the centripetal force, and you're gonna say this is equals to mass times acceleration, v square by g. But v square is something that we know. V square is 2gr, right? So if you do that, T plus mg becomes equals to what? M times 2gr divided by g. G cancels. Okay, something wrong. Oh, sorry, this is not mv square by g, it's mv square by r. So 2gr divided by r cancels. So you get tension equals to how much, guys? Mg. I am waiting for you to answer the third part. The third part means the tension when the bob is located at this location and the tension goes like this. Can you find out the tension at that location? If you understood this one, then tell me how to find out the tension at 60 degrees. It here. Now I'm going to ignore this part. X is where the ball was. Now the ball is at this position. Let's call this point as X, new position X. And the body is going in this direction with v velocity. Cool. Right. Now, what can we say about this FBD? Okay. So the tension would be like this. What is this angle, guys? What does tension make with the vertical? Well, it makes 60. Right. And what does mg make with the direction of tension? Well, this angle will also be 60 because vertically opposite angles. And you gotta understand that the acceleration is happening in this direction and it's equals to v square by r. But we gotta figure out how much this v is. So is there a way to find that out? Awesome, Satvik. You seem to have nailed this concept. So we know this h value is how much? It's equals to well, r into 1 minus cos of theta. We have discussed this in the beginning only, right? So if it goes up by an angle of theta, so the height gained by the body is how much? It's r1 minus cos theta. So that's r1 minus cos 60. Cos 60 is half, so 1 minus half is half. So it has gone by a height of r by 2. So this is nothing but r by 2. This height is how much? R by 2. So conservation of energy says whatever is the energy given at the bottom, so half mv square, that's the only kinetic energy, becomes equals to what? Half mu square is equals to half mv square plus mgh. Energy conservation, guys. So you're gonna say okay, half m into 6gr becomes equals to half mv square plus mg r by 2, because h is r by 2. We figured it out. Okay, so it's like 3gr minus, yeah, actually you can cancel out all the m's, right? So you have like 3gr minus gr by 2 gives me half v square. So from here, can you tell me what is the velocity there? Actually, you know what? I don't need v. I need v square. Give me how much is v square. It's going to be 5 gr. What am I going to do with this v square? I'm going to, yes. So I'm going to plug it here. When I write the equation, guys, remember, I cannot write T minus mg because there is a component of mg which is acting, right? Yeah. So there will be two components. Let me get the green. Okay. So this component right here is mg cos 60, which is like mg by 2, and this component is how much? Mg root 3 by 2. Which do you think will we take? Okay. So I'm gonna do something like, okay, tension minus mg by 2 is equals to what, guys? M into v square by r. This is from NLM. Now plug in the values and give me the answer. Mg and m into 5g. Yeah, it should be 11 mg by 2, guys. Should be 11 mg. So your tension should come out to be 11 mg by 2. So here is a question. When I have a bob at the bottommost location, and what if I send it with with a velocity that's, see, if I give a velocity of under root 2 gr, can you tell me what's going to happen? There is a significance for this number. What exactly does under root 2 gr stand for? Yes, it will reach this point right here. It reaches this point right here, and up to here there is no complicacy. Like under root 2 gr means it goes up to this point and then it comes down. Okay, at root 5 gr, it goes up to this point right here, and it does like a complete circular motion. So that's root 5 gr. Okay, so like if this is A, this is B, then for u equals to root 2 gr, the point reaches A, traces back the circular path and comes back again. So as long as your velocity is less than root 2 gr, it's going to do this circular motion and then come back, retrace its path. If your velocity is if your velocity is greater than under root of 5 gr, we know that this is going to do a complete circular motion. Now my question to you guys is, what if I give something in between, right? Like for example, if I give you that the velocity is under root of 3 gr, let's say 3 gr. My question to you guys, is, what height does it reach? What height does it reach before it starts, going haywire and not doing a circular motion? So that's the question for you guys, which I will take. No, that's for you, root 2 gr. Let's prove it. See, half mv square needs to be equals to what? Mg into r, right? So because here the velocity would be u and it gains a height of r, so the potential energy will be mgr. So you're gonna say half mu square becomes equals to mgr. So from here you can see under root 2 gr is the velocity for which the body reaches this A position. So yeah, root 2 gr is that lower limit for which the body reaches up to A and then does the circular motion. For B, to reach B you need root 5 gr. For any velocity that is between them, the body is going to reach some angle right here, and then after that it stops being a circular motion. So yeah, find me that angle. See, conservation of energy will not work because you gotta understand. See, what will you do? We will say, okay, sir. Okay, why is my pen not working? Okay, it's working now. Okay, so sorry. So yeah, you cannot use conservation of energy because what you're gonna say, okay, half the kinetic energy at the bottom plus potential energy at the bottom will be equal to kinetic energy at the top plus potential energy at the top, right? You're gonna say this, but what do you take the kinetic energy at the top? Will you take it 0? No, Trisha, why would you assume it to be rest? You know ki after this point, is it gonna just fall back like this? if that is the case, and we can assume that it can directly fall down like this, then I will agree with you. But from experience, like from you do this yourself, like do a little bit of speed. You have your ID card, I've showed this in class, okay? So you can go like it can go something like this. So at the end, when it's breaking that pattern of circular motion, it is not coming back down on a straight path. It is actually going to go like a parabolic motion. Okay, it's not going to follow that circular motion, but it is going to go, and it is going to have some velocity. So you cannot consider kinetic energy to be zero at that point. So what do you do then? Well, in that case, I find the value of the velocity at that point. I know for fact one thing, and this is always true, and you have to remember this. Okay, remember this, because this is a misconception. Everybody feels like at that point velocity becomes zero, but it's not. Velocity becomes zero, something else becomes zero at this point. Take a wild guess. Take a wild guess what becomes zero at that point. Come on, Ritoban, help me out here. What becomes zero at that point when the body stops moving in a circular motion? Awesome, Sharmishta. Tension becomes zero at that point, right? Because you have to understand, whenever the string becomes slack, that is the point where the body stops being in a circular motion, and that is the point where it loses that circular motion. It becomes like a parabolic motion, right? So we have to essentially put that condition that tension becomes equals to zero, right? So if tension becomes equals to zero at that point, then what is the only force acting downwards? So if I make the FBD of the block, the only force which is acting is mg, like this, and the body is still feeling that v square by r in that direction, right? So what am I supposed to do? Well, take the goddamn component of mg. Okay, so find out the component of mg, because if this angle here is theta and I have dropped a perpendicular, don't we know this angle? How much is this angle right here? 90 minus theta. If this is 90 minus theta, tell me the component of mg along this direction. This is going to be mg sine theta. So from NLM, guys, tell me what is the equation I'm going to write. I'm going to write mg sine theta is equals to what? M into v square by r. Trisha, tell me if this is a force. Okay. Okay, thank God it is not a force. M into v square, mass into acceleration. Okay, so from here we can get the kinetic energy. All you gotta do is multiply with r, divide by 2. So gr sine theta by 2 is what, guys? I think I should not have even cancelled out the m as well. So what I'm going to do is multiply with r and divide with 2. So mgr sine theta divided by 2 gives me what? mv square by 2. This equation came from NLM, and I just modified it to find out the kinetic energy at this instant. So what do I do next? Well, plug in the values. Plug in the damn values. Okay, so I'm going to push this here. Okay, I'm going to plug in the values of kinetic energy at the bottommost location, which is how much? Half into m into 3gr. What is the potential energy at the bottommost point? It is 0. What is the kinetic energy at the topmost point? Well, mgr sine theta by 2. Okay, mgr sine theta by 2. Okay, now the next part is this. What is the potential energy at that height? Okay, I am waiting for Kush to answer this one. What is the potential energy at that point? What is the height? No. See, if this is r, this is going to be r sine theta, right? Perpendicular, dada, opposite side. Okay. So this is r sine theta, and this height is r. So the total h is r plus r sine theta. Everybody agrees with this one? So if you understood this, then what you gotta do next is plug in the potential energy formula, and that is nothing but mg r 1 plus sine theta. 1 plus sine theta, right? So you on the left hand side you have like 1.5 mgr, and if I open this bracket, what do I get? I get like mgr plus mgr sine theta, right? Mgr sine theta. Okay, so carefully solve this equation. See, you have 1.5 mgr on the left hand side, mgr, so on the left hand side you'll have like 0.5 mgr, and on the right hand side you have like 0.5 mgr sine theta and 1 mgr sine theta, so 1.5 mgr sine theta, right? So mgr cancels, sine theta becomes equals to I believe this is 1 by 3, right? So your theta will be sine inverse of 1 by 3. So the body will go up by height of sine inverse of 1 by 3. Guys, remember, this is not part of theory. Okay, so that's why I didn't do it in class. But as we do questions like this, you get more and more insight into what is vertical circular motion. Paste it here. Okay, so again I have a question for you. What is that question? What should be the value of theta, or what should be u so that theta becomes equals to 30 degrees? Okay, so I hope you understood the question. What should be the value of the initial velocity with which I send the body, so that when it reaches angle 30 beyond that horizontal point, the body stops being in a circular motion? Okay, so what should be the value of u so that the body is able to maintain circular motion up to 30 degrees from the horizontal? I hope that question makes sense. Someone new joined, I don't know who. Bhargav has joined. Welcome, Bhargav. Do you have any doubts? Okay, just here to enjoy the show, is it? Okay, guys. So tell me if you got the answer to this question. Anybody got the answer to this question? Come on. You just have to retrace your path. And in this case, just instead of sine, see, in this case, we knew u, and we had to find out sine theta. Same process you gotta do, but this time you know sine theta, but you'll not know the value of u. So nothing changes in the process. So I feel like you should be able to do this, because I did like a similar question here. Theta is 30 degrees. So if this is 30 degrees, and if I make the FBD for the body, okay, then we know ki if this is 30 degrees, then mg makes what angle with the with this? What is this angle? This is 60 degrees. Okay, so can you tell me what will be the component of mg in this direction? Well, mg root 3 by 2. Yes. Damn. Okay, so if this is 60 degrees, guys, so if the angle here is 30 degrees, then right here this angle is going to be 60 degrees. So the component of mg is going to be mg root 3 by 2. However, this force is going to create a centripetal force that is equals to v square by r. So from NLM, you're gonna say mg root 3 by 2, ladies and gentlemen, will be equal to what? Mv square by r. Multiply this whole thing with r and divide by 2, and I hope you know why. Huh? What? Oh yeah, sorry, it should be mg by 2. My bad. Sorry guys. Sorry. Mg cos 60 is mg by 2. I'm amazed how I made this mistake. Okay. So if I continue this, multiply this with r and divide by 2. So this becomes mgr divided by 4, and on the right hand side it becomes mv square by 2. So that means now I know the kinetic energy at this point. Okay, from conservation of energy, I know that the kinetic energy plus potential energy at the bottom will be equal to kinetic energy on top plus potential energy at top, right? So kinetic energy at the bottom is just half mu square, and we don't know the value of u. Okay. However, kinetic energy on the top is something that we know. It's mgr by 4. Kush, tell me how much is the potential energy? How much is this h? Yeah, how much is theta? Theta is 30 degrees. So 1 plus sine 30 is half. That's 3 by 2. So mg into 3r by 2. Do we agree? Yes. So m cancels. U square becomes equals to, well, I want to multiply everything with 4. So this becomes, oh well, I want to multiply everything with 2. So this becomes what? GR by 2, and this becomes just 3GR, right? So 3 plus half, guys, how much is 3.5? Like 7 by 2. So U would be equals to under root of 7 by 2 GR. Well, I guess you're close, but yeah, the correct answer would be under root of 7 by 2 GR, which is like under root of 3.5 GR. So please let me know if you understood this. You should be able to, because again, we started from the basics and basics and basics.